Today we're diving into a jaw-dropping discovery that takes us back 14,300 years when an extreme solar storm slammed into Earth, leaving a lasting impact. Let's jump right in. Scientists from the University of Leeds and other institutions recently analyzed ancient tree rings found in the eroded banks of the Druse River in the southern French Alps. These tree rings, preserved as subfossil trunks, revealed an unprecedented spike in radiocarbon levels, precisely dating back to 14,300 years ago. This spike in radiocarbon was caused by an extreme solar storm that hurled massive amounts of energetic particles into Earth's atmosphere. These findings were cross-referenced with beryllium measurements, confirming the colossal solar event. Professor Edouard Bard from Collège de France explains, radiocarbon is continuously produced in the upper atmosphere through a chain of reactions initiated by cosmic rays. Extreme solar events like solar flares and coronal mass ejections can create short-lived bursts of energetic particles, leaving a significant radiocarbon footprint. But what does this mean for us today? Leeds University professor Tim Heaton warns, extreme solar storms can have massive impacts on Earth. These superstorms could severely damage our power grids, leading to widespread and prolonged blackouts. They could also render our satellites, crucial for navigation and communication, inoperable and pose serious radiation risks to astronauts. These extreme solar events, known as Miyake events, have occurred 9 times in the last 15,000 years. The most recent confirmed events happened in AD 993 and AD 774. This newly identified event, however, is the largest so far, dwarfing the previous ones by almost double. Professor Bard highlights, direct instrumental measurements of solar activity only began in the 17th century with the counting of sunspots. Today, we have detailed records from ground observatories, space probes, and satellites, but these short-term records aren't enough to fully understand the sun's behavior. Radiocarbon measured in tree rings and beryllium in polar ice cores provide the best way to understand the sun's past behavior. This knowledge is crucial as we strive to predict and mitigate future risks. Dr. Cécile Miramont from Aix-en-Provence University remarks, finding such a well-preserved collection of trees is extraordinary. By comparing the widths of individual tree rings across multiple trunks, we used a method called dendrochronology to piece together a longer timeline. This allowed us to uncover invaluable information about past environmental changes and measure radiocarbon during an unexplored period of solar activity. This incredible discovery was made possible by meticulously analyzing the ancient tree rings. The research team carefully sliced the subfossil trunks into tiny tree rings for detailed examination. By doing this, they could pinpoint the exact moment when the radiocarbon levels spiked, linking it to a massive solar event. These massive solar storms, or Miyake events, are named after Japanese physicist Fusa Miyake, who first identified them. These events are characterized by sudden and drastic increases in radiocarbon levels, indicating a significant influx of solar radiation. If such an event were to occur today, the consequences would be catastrophic. Our modern technological society heavily relies on satellites for communication, navigation, and weather forecasting. A solar storm of this magnitude could knock out satellites, disrupt power grids, and cause widespread communication failures. Understanding these past events helps us prepare for future solar storms. By studying tree rings and ice cores, scientists can create models to predict the frequency and intensity of these events. This knowledge is crucial for developing strategies to protect our technology and infrastructure. While we have made significant advancements in monitoring solar activity, there's still much to learn. The sun's behavior is complex and influenced by various factors. Continuous observation and research are essential for improving our understanding and preparedness. This groundbreaking discovery not only answers key questions, but also opens the door to new ones. As we continue to explore the mysteries of our universe, each finding brings us one step closer to understanding our past and preparing for our future. Don't forget to like, subscribe, and hit the bell icon to stay updated with the latest in space and science. Until next time, keep looking up.